So we are dealing with the electric flux series, and it is the first problem for the electric flux series. This is problem number 3.19, and the problem is stating a very long uniformly charged thread oriented along the axis of a circle of radius capital R rests on its center with one of the ends. The charge of the thread per unit length is equal to lambda. Then find the flux of the vector E across the circle area. So if we try to understand this problem, so let us first of all understand the diagrammatic aspect of the problem. So this is a linear charge distribution that we have, and it is having positive charge distributed all over it, having surface charge density as lambda, which is mentioned in the problem, lambda charge per unit length. So this is given in the problem, and we are considering over here a circle like this through which the flux is to be calculated. So if we understand the patch of this area, this is the area through which the flux is to be calculated, and the radius is referred as capital R. So the first thing that we understand over here is due to this line charge, so at a distance small r, if we consider a patch of thickness dr, so over here we will have two components of electric field. The one component will be in the x direction and the another component will be in the y direction. The component in the x direction will not contribute for any electric flux. The Ex component will not contribute for any electric flux as Ex perpendicular to area vector. So we will have another component Ey. So Ex and Ey have the same value. We have seen in many of the previous problems that magnitude of Ex and magnitude of Ey is same, and it is written as lambda upon 4 pi epsilon naught r. So this is the value that we write, k lambda by r, or lambda upon 4 pi epsilon naught r. So over here at this distance, if we calculate elemental flux, then it is equal to lambda upon 4 pi epsilon naught r multiply by the area of the patch that we have is 2 pi r dr. So this is the flux that we have, and if we integrate this value for the total length 0 to r, we get the net flux value. So the net flux that we have is equal to lambda upon 2 epsilon naught integration of dr from 0 to r. So r and r cancel out, pi cancel out 2. So we get the final answer as lambda capital R by 2 epsilon naught. So this is the answer for this problem which we are looking for.